Hi and welcome back. Let's make our first request with AO HTTP. Here in this project, I'm just going to create a new file just for testing AO HTTP, and it's going to be called async request.py. By the way, the code for this is linked in each lecture and is available, maybe in a slightly different setup, but nonetheless, there's going to be a samples folder for you to look at these codes that we're going to write over these lectures. And then, of course, at the end as well, when we turn the full thing into an asynchronous scraper, the full code is available as well. So in order to make our first web request, the first thing we need to do is, of course, to install AO HTTP. Now, soon we're going to look at how to handle dependencies in Python projects a bit better. But for now, we're going to stick with installing things directly in PyCharm by doing, going over to our project interpreter, and there with the plus installing AO HTTP. The current version that I'm using is 3.0.5. This may be different when you're using it, but don't worry. If there are any breaking changes, we will re-record with a new version soon. So if you install this and you notice that things don't work quite the way you expect, just say in the course Q&A, and we will re-record as soon as possible. Okay, just install this package, and this is all we need to install. So when that's installed, you can close this window, and we can begin using it. So that's it, done. We can press OK, and now we can import AO HTTP. So let's first start with fetching a single page. First thing we need to do is create the coroutine. Remember, this is like a generator that can suspend and resume their execution at any time by using a wait. So we're going to do async def fetch page, and what we're going to pass to this function is the URL that we want to fetch. Now the next thing we do is we must tell AO HTTP to create a client session. A client session just essentially creates a bunch of connections and puts them in a pool, pretty much like a thread pool, except it's a connection pool, so that we can reuse them without having to create new connections each time. So what we're going to do is a bit of a new bit of syntax. Async with AO HTTP.client session as session. All that's happening here is we are doing a normal context manager. We're creating this new client session, which is a connection pool, and also a cookie storage. We're going to talk more about that soon. We're calling it session, but because it's async, what happens in an async in an async context manager is that it can have a yield in the enter or in the exit methods, or in both. So essentially, it's just a way of potentially suspending the execution of the context manager when it starts, or suspending it when it ends and resuming it. Just adds like a new point where it can suspend and resume, just in case you want to do something a bit heavy duty inside the context manager. It allows you to suspend and resume at the start or at the end of the context manager. That's the only difference with the normal context manager and the async context manager. For more information about this, instead of enter and exit, the new methods are aEnter and aExit. Okay, we're not going to get into too much depth about creating your own asynchronous context managers. Just know that if you want to create an asynchronous context manager where you can do an await or a yield inside it, you have to use aEnter and aExit instead of enter and exit. Nonetheless, just a bit of an aside there. Then we're going to do async with session.get, and we're going to get the URL as response. And then we're going to return the response status code. This can be our first task. This is a coroutine that, first of all, creates a session. Then it sort of gets the URL we passed in. It asks the server for the contents, calls it response, and then returns the response status. But of course, before returning the response status, it can potentially be suspended here or here, when it starts or when it ends. So when we can, for example, get the URL or send the request to the server and then suspend while we wait for data to come back, When the data comes back, will be at the at the end of the enter section of the generator. And we can continue execution, and then we can get the status. And this is not asynchronous, this is just a normal return. So then the function would end there. Remember, the only purpose of Async IO and these asynchronous functions is to potentially suspend execution at any point and resume it after. Placing these things in the correct places means that we can suspend execution when we're waiting, and we can resume execution once we want to stop waiting. Okay. Now, we must have a task scheduler that will do the, .send or the next. Remember, this is just yield from. Inside here, there are awaits, which are yield froms. So we need something that is going to do this send or this next. And now, as of Python 3.4, I believe, we have that, which is the Async IO library. If you've watched the talks, which I hope you did, you will have seen Async IO mentioned a couple of times. The Async IO library comes built in Python, and it's very small. It's not that small, but it's fairly small, the things we have to know. And it allows us to schedule and manage these coroutines, these tasks. It's really straightforward to use, at least the way we're going to do it right now. There's a bit more to use than what we'll cover, but in order to use it in some ways, it's fairly straightforward. All we do is we get an event loop, and then we do loop run until complete fetch page of, for example, google.com. When you call fetch page, you don't get the response status. We know this already from what we've looked at earlier. When you call fetch page, what you get is a coroutine object. So this isn't actually giving you the response, even though we're calling the function. All this is doing is creating the coroutine in the background that you can then send or next to. When you do that, it sort of goes through each resume and response. So what this run until complete is doing is it's using this event loop in order to continually resume this function until it's completed. Okay. So we can run this, we can right-click the async request and run it. And of course, we didn't really print anything, but we can print response status here, and you'll see that something does come back. Yep, 200, which means it's all okay. As you can see, this did run. So this is the simplest way that we can get an event loop and run a task. And a task is just an async function that has been defined. Okay, all we need is to get the event loop and run it until it's complete. If you wanted to make more asynchronous requests, we're going to do that just now as well. What we're going to do first of all is import time, so we can start measuring how long this takes. Then, before we do any of the session or anything like that, we're going to do page start is time.time. And right before we return, we're going to print that the page took time.time minus page start. I call it state. No, should be start. There. Okay, if we run this again, you'll see that it says page took 0.17 seconds, so it was pretty quick. The program as a whole took a bit longer, but that's because it involves creating the event loop and starting new tasks, scheduling them, and so forth. But the page request itself only took 0.17 seconds. If you ran this using the requests library like we did earlier on, it would take more or less the same amount of time. Okay, there would be no difference, just because all we're doing here is running a single request. If you want to run multiple requests, though, we can do that very easily. We'll say something like tasks is, and now we're going to do a list comprehension where we're going to fetch page of google.com for I in range 50, let's say. Okay, so now we've got 50 coroutine objects that need to be ran. So how we're going to do that? Well, we're going to say loop run all these tasks until they have been completed. But we can only pass a single task to the run until complete function. So Async IO comes with a pretty handy function that allows us to, collect a bunch of tasks together and run them as a single task so that it's a bit easier to do this. And all that is async IO.gather. And we're going to pass it all the tasks as arguments. So it will be tasks 0, tasks 1, tasks 2, tasks 3, and so on until 50. Or, as you already know, we can use argument unpacking to do star tasks. Okay. Now, as part of this, I'm also going to time this. So I'm going to say start is time.time, and end is going to be all took time.time minus start. Notice how I'm only measuring the loop run until complete. I'm not measuring the creation of the tasks, because this is pretty much instant. No requests are actually happening in this line. Only the coroutines have been created. Then when we start running them, this does the .send to the first task and runs it up until the async IO. Then that suspends, and this moves on to the second one and moves it up till there. Then this suspends and moves on to the third one. So first of all 50 tasks will end up here. Then one by one they will be moved here. And then one by one they will return. But of course, they may take different amounts of time. So one request to google.com may take 0.5 seconds if it's a very slow one. Another one may take 0.1 seconds. So as soon as you start doing this and you only resume execution when you are ready to do so, you'll see that these tasks are not necessarily all going to finish in the same order. Okay, so let's press play. And as you can see, that was extremely quickly. We've got some tasks that took 0.32 seconds. And as they finish more or less in order, we can see that at the bottom, some of them took 0.46 seconds. And in total, it took 0.48 seconds. Not the addition of all of these things, but rather the longest one plus a couple of milliseconds just to set up the event loop and, do the scheduling of the tasks and so forth. So this is amazing, because now instead of having to wait for each page to finish before we get the next one, we can essentially just send the 50 requests out to Google and just wait until they come back. Now, of course, that's going to depend on whether Google can deal with 50 requests at the same time. Google is a massive company, has a lot of servers, and they can handle 50 requests at the same time. Other websites won't be able to handle 50 requests at the same time, and if you do that, you may actually break them. You may actually break the site, or they may say, no, you cannot do 50 requests at a time. I'm going to be very slow in responding to you in order to prevent you from breaking their server. So that's a couple of things you need to be careful about. But as you can see with Google, this is all you need in order to get 50 pages asynchronously. So again, what we've done is we've created our task, and using AO HTTP, which supports these async with statements, we have created our session and then used that, which gives us a connection pool to get each URL that we passed in. And at the end, we've returned the response status code. That's just to, get something back from there. And then in order to run them, we've got an event loop from the Async IO framework. We've created all our tasks, which are just these functions. And then we've run them all until complete by using Async IO gather. And gather collects all our tasks and allows them to run as one in this run until complete. Otherwise, you would have to do run until complete once for each task, which would be a bit more tedious. So Async IO gather, pretty good for that. Now, that's it for this video. I just wanted to show you how to go about making these asynchronous requests. Feel free to compare this with your synchronous code. If you open app.py, by the way, you can see this is a synchronous code. So if you replace this for google.com and put a couple of timing functions in here, you'll see how long that takes. It's about 10 seconds, whereas this was about 0.5 seconds. So now what we're going to do is we're going to just make this a bit more efficient, get a couple of functions in here to deal with getting multiple pages more efficiently, and then we'll move on to turning our scraper into an asynchronous scraper. I'll see you on the next video.